On June 19, 2026, Ukraine revealed of drone attacks stretching from the forest near Lyman to railways, radar sites, and energy facilities deep inside occupied Crimea. The footage did not show one battlefield. It showed an entire military system coming under pressure. An FPV drone moved through thick trees to hunt Russian infantry. Two explosive ground robots advanced toward a fort. Behind the front, fuel trucks burned. A locomotive was struck, and military vehicles were attacked while still moving toward their positions. Farther south, Ukrainian reports said drones targeted the Hlibivske underground gas storage facility, a related technical center at Vinnikov, a locomotive near Rozdal, the Rapanic radar, and a P-18 Terek air surveillance system. Field air defense vehicles and a Russian command post in Donetsk were also placed in the strike chain. These attacks may look separate, but together they point to something far more serious. Ukraine may be building a connected system that can track soldiers, follow supplies, weaken air defense, and strike the rear before Russia can react. How far has this network already reached? And can Moscow protect its logistics before the rear becomes as dangerous as the front? In the Lyman sector, the forest is no longer a reliable shield for Russian infantry. Small groups move through narrow paths, broken tree lines, and old fighting positions because these routes offer cover from direct fire. They spread out, avoid large formations, and try to reduce the chance of being seen by artillery observers. But the air above them has changed the risk. A reconnaissance drone can watch several paths at once and notice movement that would be almost invisible from the ground. A branch moving in the wrong direction, a figure crossing a clearing, or a brief gap between trees can reveal a route. Once confirmed, the position can be passed to an FPV team. That is where observation becomes attack. The strike drone does not need to follow the same path as the infantry. It can drop below the tree line, turn around branches, and approach from a side the soldier is not watching. Pilots guide these drones through gaps in the foliage and keep the target in view until the final seconds. The forest still blocks sight from the ground, but it no longer blocks observation from every angle. That pressure also changes where Russian troops choose to hide. Bushes, tall grass, small sheds, and damaged buildings may provide temporary cover. Yet once a drone marks the location, that cover can become a trap. If one position is struck, nearby escape routes may also come under watch. A soldier leaving can expose the direction of a trench, shelter, or supply point. One detected movement can lead the drone team toward a wider network of positions. To cross these dangerous spaces faster, Russian units use motorcycles and ATVs. These vehicles are quicker than foot movement, easier to hide than armored machines, and able to cross ground that heavy equipment cannot use. They also carry fewer soldiers, which reduces the loss from one strike. However, speed only helps before the route is found. Engines can be heard, dust can rise above dry ground, and repeated travel creates patterns that reconnaissance teams can study. Once an FPV approaches from behind or above, the rider may have only seconds to react. The same vehicles are used to keep frontline positions supplied. Some ATVs pull trailers carrying ammunition, food, water, batteries, or medical items. Destroying one can delay a unit, force soldiers to carry loads by hand, or push commanders toward a more dangerous route. The loss of one machine can create pressure along a larger supply line. Lyman is well suited to this kind of contest. The area contains thick woods, narrow roads, broken ground, and many hidden approaches. That terrain helps small groups move quietly, but it also creates predictable corridors. A drone unit working in the same sector for weeks can learn which paths are used most often, where troops gather, and where vehicles must slow down. Local knowledge can become as important as drone speed. Still, this does not mean Ukraine controls every forest route. Dense leaves can block cameras, bad weather can reduce visibility, and electronic warfare can break the signal between pilot and aircraft. Some FPV drones miss, crash, or lose contact before reaching the target. Published footage shows successful missions more often than failed ones, so it cannot reveal the full picture. Even with those limits, Russian movement through the forest is becoming harder to hide. And when troops go deeper underground to escape that pressure, Ukraine begins using a different system designed to reach shelters that flying drones may not fully destroy. The attack on the shelter shows why Ukraine is dividing battlefield tasks between different unmanned systems. A reconnaissance drone first identifies the entrance from above and keeps the position under watch. The camera can follow movement around the roof, nearby trenches, and any route leading away from the site. Once the opening is confirmed, the strike is handed to a vehicle that can approach from ground level. That change in direction creates a new problem for the defenders inside. The first kamikaze UGV moves slowly across the damaged ground and stops close to the entrance. It carries explosives directly to the strongest part of the position where an aerial FPV may not create enough pressure. The blast tears at the outer cover, damages the doorway, and may force anyone inside to move deeper. More importantly, it weakens the structure for a second attack. The second robot uses the damage created by the first explosion. It approaches the same point and detonates against a shelter that has already lost part of its protection. The second blast can push broken timber, soil, and sandbags inward, while the front section of the roof may collapse over the entrance. This is why two smaller attacks can sometimes achieve more than one strike carrying the same total weight. A field shelter is rarely a simple hole in the ground. Russian troops may reinforce it with logs, packed earth, metal sheets, sandbags, concrete pieces, or material taken from destroyed buildings. These layers are designed to spread the force of an explosion and protect the deeper chamber. A weapon exploding outside may damage the entrance without destroying the space behind it. Repeated pressure is meant to remove those layers one by one. Ground robots can also carry a larger explosive charge than many small FPV drones. They do not need wings, lifting power, or the same light frame required for flight. Their weight can be used for batteries, armor, cargo, or explosives. That gives commanders another option when the target is too strong for a light drone, but too dangerous for soldiers to approach. Their value reaches far beyond direct attacks. Ukrainian ground systems are used to carry ammunition, water, food, batteries, and medical equipment. Other models evacuate wounded troops, place mines, support engineering work, or carry electronic equipment into exposed areas. Ukraine's defense ministry reported 10,281 logistics and evacuation missions by UGVs in April 2026, an average of 367 missions each day. This shows that robots are moving from rare experiments toward regular battlefield service. However, these machines are not independent hunters. Mud can trap their wheels, shell holes can overturn them, and trenches or fallen trees can block the route. Wire may catch moving parts, while electronic warfare can weaken the control signal. Operators often need an aerial drone to guide the vehicle, watch for obstacles, and relay communications from above. The attack, therefore, depended on coordination, rather than one machine acting alone. The aerial platform found the target. The first UGV opened the position, and the second delivered the heavier final effect. Such teamwork can reduce the need to send soldiers toward a defended entrance, but it cannot remove every technical risk. These robots may break a shelter at the front, yet the troops inside are only one part of the wider system. To reduce Russia's ability to rebuild positions and replace supplies, Ukraine must now reach the transport network that keeps those defenses operating. That wider mission begins beyond the immediate fighting line. Ukraine's campaign against Russian logistics is moving beyond isolated vehicle strikes and toward a wider effort to disrupt the system behind the front. According to Ukrainian claims and the source transcript, intelligence units and drone formations have targeted ammunition trucks, troop carriers, fuel tankers, supply robots, storage points, locomotives, and freight trains. These vehicles may not look as important as tanks, but they carry what keeps an army moving. Fuel powers armored units and generators. Ammunition feeds artillery. Spare parts keep damaged equipment in service. Food, water, batteries, and medical supplies support the soldiers holding each position. The transcript attributes part of the April and May campaign to Ukraine's intelligence service, the UR. However, public material does not prove that every strike belonged to one centrally directed operation. So, the broader pattern is clearer than the exact command chain. A convoy does not have to be destroyed from one end to the other to lose its value. A strike on the lead vehicle can block a narrow road, while a burning fuel truck can create smoke, heat, and confusion across the route. Drivers may stop, turn around, or leave the road. Recovery teams and engineers then have to enter an area that may still be watched from above. One successful hit can therefore delay many vehicles that were never directly attacked. Russia can respond by changing routes, splitting cargo into smaller groups, increasing escorts, or moving at night. Each answer brings a new cost. Longer roads consume more fuel. Smaller loads require more trips. Heavy protection pulls personnel away from other duties. Night movement may reduce visual detection, but thermal cameras and repeated route analysis can still expose patterns. The pressure comes from delay and uncertainty as much as from physical damage. The scale became larger on June 19th when Ukraine's Unmanned Systems Forces reported strikes against energy, transport, and surveillance targets in occupied Crimea. Ukrainian accounts said the 413th raid unit hit the Hlibivske underground gas storage site near Dzern, while the 414th Birds of Magyar formation attacked a related center at Vinnytsia. Published footage showed explosions and fire near the target area, although the full level of damage inside the underground facility has not been independently confirmed. Hlibivske matters because it supports the wider gas network on the peninsula. Ukrainian reporting describes it as Crimea's only underground gas storage facility used to balance demand and maintain pressure in the transport system. Its main role is civilian and industrial, but energy networks also support the rear area where military bases, repair sites, communications equipment, and transport services operate. A strike there may not stop a Russian unit at once, yet it can add pressure to a system already carrying wartime demands. The same operation reportedly included a locomotive near Rozdoln. Railways can move far more fuel, shells, vehicles, and spare parts than road convoys. So even temporary disruption can affect schedules across several supply points. Still, one damaged locomotive does not prove that an entire rail line has been cut for a long period. Russia may replace the engine, repair the track, or redirect cargo, but each action costs time. Crimea serves Russia as a logistics hub, an air defense zone, and a support base for operations in southern Ukraine. By striking transport and energy targets together, Kyiv can force Moscow to protect more sites far from the front. That creates the next problem for Ukraine, because deeper attacks become harder while Russian radar continues to watch the sky. The fight over Russian movement now begins with the systems that watch the sky. Ukraine's 414th Unmanned Systems Brigade, known as Birds of Magyar, was reported to have struck a P-18 Terek radar near Novovasilivka in occupied Zaporizhzhia. The P-18 is an early warning system designed to detect aircraft and aerial targets at long range. Removing it does not erase Russia's air picture, but it can weaken part of the warning network and create pressure on nearby crews. A separate Ukrainian unit reported hitting a repellent radar near Kamyansky in occupied Crimea. Repellent is a portable system built to detect small drones and other low-flying targets. The source transcript placed the value of one radar between $10 and $20 million. Although it did not clearly identify the model, equipment package, or replacement cost, its importance may be measured less by price than by the area it helps protect. When a radar is damaged, Russia can move another system into the sector to connect information from nearby stations or increase air defense patrols. Yet, each response creates work elsewhere. Replacement equipment must travel, crews must set up a position, and antennas may need to operate longer. Moving radar units often can improve survival, but it also reduces the time they spend watching the air. That pressure opens the path towards shorter-range defenses. 2 MTLB armored vehicles fitted with Zu-23 anti-aircraft guns were reported struck near Smolyaninov and Tarasivka in Luhansk. These field systems offer a cheaper way to fire at low-flying drones than using surface-to-air missiles. They can move with convoys, react quickly, and create a dangerous wall of gunfire. However, the gunner must see the approaching aircraft and turn the weapon before the FPV reaches a blind angle. A small drone flying close to roads, trees, or damaged buildings can remain below the clearest radar view. It may approach from behind the vehicle or use terrain to hide the final seconds of flight. The Zu-23 remains dangerous, but its effectiveness depends on warning time, crew alertness, and a clear line of fire. This contest becomes harder when the protected target is moving. A Russian BM-21 Grad presents that problem. The launcher normally leaves cover, reaches a firing point, releases a group of 122 mm rockets, and withdraws before Ukrainian forces can answer. On June 19th, Ukraine's 42nd Mechanized Brigade released footage that it said showed reconnaissance drones tracking a Grad after it fired and strike drones destroying it near a wooded area. Attacking during this cycle can stop another launch or catch the vehicle before it disappears. Nemesis and Phoenix were reported operating against other moving targets across Donetsk, Luhansk, and Zaporizhzhia. Ukrainian accounts credited the 412th Nemesis Brigade with attacks on fuel vehicles and linked the Phoenix Group with strikes on Russian logistics transport. Other formations, including K2 and the first separate Unmanned Systems Center, were assigned different areas and target types. This division suggests a campaign built around several teams rather than one unit covering the entire front. Such coordination matters because each target creates a different tactical problem. Radar must be found before it moves. An anti-aircraft vehicle must be approached from a weak direction. A Grad must be tracked through its firing cycle, while a convoy may require repeated attacks along the road. In Donetsk, Ukraine is moving beyond the hunt for vehicles and aiming at the places that help Russian forces think, communicate, and fight. Near Velika Novosilka, Ukraine's Unmanned Systems Forces said the 412th Nemesis Brigade struck a command and observation post linked to Russia's 656th Motor Rifle Regiment of the 29th Combined Arms Army. Such a position can receive reports from forward troops, track battlefield changes, pass movement orders, and connect infantry with artillery support. If that node is damaged, the effect may reach several units at once, which makes it more important than one armored vehicle. The attack was carried out in several waves. A heavy strike drone can hit the roof first, break the cover, or expose the rooms below. A later aircraft can aim at communications equipment, power supplies, parked vehicles, or the section used by commanders. This method increases pressure on a target that may be reinforced, spread across several rooms, or protected by earth and concrete. It also gives personnel less time to recover equipment before another impact. Repeated strikes do not automatically mean the whole regiment loses command. Russian forces can use backup radios, alternate posts, field cables, and lower-level officers to keep operations moving. Some staff may leave before the second attack, while data may already be copied elsewhere. The accurate conclusion is that Ukraine reported hitting one command position, not that the entire Russian formation was paralyzed. That distinction becomes important when the camera turns toward armored targets. Separate footage showed a Russian tank hidden inside a tree line in the Donetsk sector. From the ground, a vehicle under branches can be difficult to identify. From above, details may reveal it. Fresh track marks can lead into the trees. A warm engine can appear on a thermal camera. Cut branches, disturbed soil, or crew movement can expose the hiding place. Once found, the tank faces a different attack. Several FPV drones may be needed because the first impact does not always reach a critical part. Russian tanks carry heavy protection around the front and sides, while the roof, engine deck, optics, tracks, and rear section are exposed. One drone may damage the running gear and stop movement. Another can strike the engine area, while a later attack may target the turret roof or ammunition zone. The aim is to turn a protected vehicle into a fixed object that can be hit again. The result must be described with care. A flash, smoke cloud, or lost video signal proves that an attack occurred, but it does not always prove final destruction. Hit is correct when the damage cannot be seen. Damaged is stronger when the vehicle stops, burns briefly, or loses a major part. Destroyed should be saved for clear evidence such as a long fire, an internal ammunition explosion, a separated turret, or later images showing a wreck beyond repair. This difference matters because battlefield videos are selected for public release. They usually show successful missions, while misses, electronic interference, failed warheads, and recoverable damage receive less attention. Russia can sometimes tow a disabled tank away, replace damaged optics, repair tracks, or use the hull for spare parts. Ukraine may still gain a tactical benefit by removing it from action during a critical period, even when the machine is not permanently lost. Taken together, These targets represent the working parts of a military operation. Infantry must reach the line. Shelters keep them alive. Trucks bring fuel and ammunition. Railways move heavy cargo. Radar watches the air. Grad launchers and tanks provide firepower. Command posts connect those elements and decide where they move. Ukraine is trying to place pressure across this chain. So, trouble at one point can reduce the value of another. These attacks do not prove that drones can replace infantry, artillery, aircraft, or armored forces. They show something practical. Unmanned systems can raise the cost of movement, shorten the life of exposed positions, and force commanders to spend more time hiding, repairing, and relocating. That change leads to the larger question of what this campaign means for the future battlefield. The battlefield from Lyman to Crimea shows that unmanned warfare is no longer built around one drone and one target. Ukraine is using reconnaissance UAVs, FPV drones, heavy bombers, long-range systems, and ground robots as parts of the same combat network. Each platform has a different role. Some watch movement. Others attack shelters, vehicles, radar sites, rail links, or support facilities. The larger effect comes from how these systems work together, not from one strike alone. The most serious pressure may be the change in Russian behavior. A commander who expects constant surveillance must move supplies in smaller groups, hide vehicles for longer periods, and protect more roads. Radar crews may have to relocate more often. Convoys may need extra escorts. Units near the front may wait longer for fuel, ammunition, repairs, or replacement equipment. None of these problems automatically stops an offensive, but together they can reduce speed and make planning less reliable. Russia still has ways to respond. Electronic warfare can break control signals. Short-range air defense can destroy low-flying drones. Camouflage can reduce visual and thermal detection. Backup radar, hidden command posts, and Russian ground robots can also lower the damage from future attacks. This means the next stage will not be decided only by which side owns more drones. It will depend on who can connect sensors, operators, communications, and weapons faster. It will also depend on who can replace lost systems, train crews, and adapt before the enemy changes tactics again. The warning from this campaign is clear. Distance from the front no longer guarantees safety. A forest path, a fuel route, a radar position, or a railway deep in the rear can all become part of the same target chain. Subscribe to Military Force for more clear analysis of the weapons, battles, and strategic changes shaping modern war.